And I was just like, oh God, let's not. I wonder if the same thing is going to hold true this month.
Let's see if. I guess it was Will was supposed to join.
Yeah, Will McClintock was on the invite, but I hadn't heard back an affirmative or not. So.
Okay. Well, maybe we should just let those guys join as they can, and push on.
Yeah, let's go ahead.
So I will. I've got your PowerPoint queued up here, Chris. Is there another way to get it into presentation mode without going into the lower right corner?
Yeah.
Yes.
From the beginning. In the beginning.
I can't seem to undock that from there, so.
Oh, okay.
So I can run it for you if you want.
Sure. So are you guys seeing the intro slide on your screen okay?
Yep.
Okay, good. So, this thing is called BAS, Bayesian Analysis for Spatial Siting. And so what I'm going to do is give you guys a little bit of intro about what's at the heart of it and why we're doing this. And then this part 2 will be Chris and Morgan are going to run a scenario demo to show you actually how you step through the system and do an actual task. And hopefully we can do that in an hour, we're thinking. So first we're going to jump straight into statistics, and I know you'll be disappointed, but they're not going to be pages of equations here. So, to understand why we're doing a Bayesian system and what Bayesian statistics or analysis methods means, we're just going to go directly into that first, and then get into the how we implement it in the system. Okay, so Bayesian thinking, or Bayesian, it's not just about statistics. It's really kind of a method of solving problems. And so, just to give you a really simple example, this kind of illustrates how we actually use this type of thinking every day in sort of very simple everyday tasks, without really realizing it. And it has nothing to do with statistics. It's just a way to solve problems that we can't really solve analytically. So here's a traffic circle, and when you come up to a traffic circle, typically you've got the music playing and you're thinking about the grocery list and various things. And if you come to a four-way stop sign, it's exactly prescribed what you're supposed to do there. You stop, you look both ways, and you go. There's no doubt about what's going to happen, at the stop sign usually. When you come to a traffic circle, though, it's a bit of a different deal. You kind of bop in there, and then you realize, oh, I got to pay attention a little bit here. There's 3 or 4 other cars coming, and so you're in your head. What your brain is doing a probabilistic calculation of what might happen at this intersection, and your goal is to get through the intersection without swapping paint with any of the other cars. So you take a look around, and your mind's calculating the speed and range to the other cars. And maybe you're even looking at some other details, like you see this person in the red car you see a little tuft of blue hair sticking above the steering wheel. It's a very old lady. You're not sure what she's going to do, but she's going very slowly. You see the person in the yellow car is texting. They're not watching at all. And so you're factoring these things into your calculation, like, okay, the red lady's going to be slow, the yellow person's not going to have any clue, and you can't really see the person in the blue car. But you can see all of a sudden this is a very difficult problem to solve. If you had to program an analytical solution for this on a computer, it would be impossible, because you'd have so many free parameters that you couldn't do it. But your brain does this easily and instinctively, just by doing this little probabilistic calculation. What are the chances of these various things happening? And you respond to that, and you adjust your speed, and you sail through, and nothing happens. So every decision we make, like a traffic circle, or whether I'm taking an umbrella to work today, or anything like that, you basically are constantly calculating the probabilities of outcomes. And that's the basic scientific method. When you took your very first science class, they talked about multiple working hypotheses and evaluating the probabilities of one of those being correct. And so we do it in everyday life, and we do it in science all the time. So it's a very simple principle. And so we'll just go on to a nice example. So this is the only equation you're going to see, is that one in the blue neon at the top. That's Bayes' theorem. And what it's really about there's a lot of different ways Bayesian thinking is used, and this is just a quick demo of one of them. And one of the things that we face with marine data, as opposed to other kinds of things, is the data is typically very sparse, typically has holes in it, and it has big uncertainties. So we're always trying to fit bad data into some sort of analytical solution where we can calculate something, and it usually doesn't work very well. It usually blows up. And so we're faced with constantly having to deal with what happens with the, when data sets have holes in them and so forth. So Reverend Bayes back in the 16th century was wondering the same kind of thing, and thought that maybe you could do something with poor data or good guesses or increasingly good guesses to try to, if not analytically calculate something, at least narrow the range of possibilities to something reasonable. And so he did this little experiment, and just think of this as a little pool table, and he had an assistant, and he put the cue ball over at one side, and then he turned his back. He didn't know where it was, and he had his assistant help him. So he has no idea where this pool table, where this cue ball is. So he guesses where it might be, somewhere on. He knows it's on the table, so you can narrow it down that far. And then you do a little probability distribution about where that ball might be. And his first guess was, well, middle of the table. That's as good as anything. So he has his assistant put a second ball on the table, and then he asks him a question. He says, "Okay, where's the ball that I'm seeking relative to the first one?" And he goes, "Well, it's to the right of the yellow ball." So he makes then based on that new information, he makes another guess, and you can draw another probability distribution that goes with that. And then his assistant puts a second ball on the table, and then he's asked another question, "Where is it?" And the answer is, well, it's to the right of the second ball as well. So we're going to guess a third time, draw a probability distribution for that, and you can see what's happening here. We're using information to narrow the range of possibilities, and then maybe you'll put one more ball down, draw another distribution. And now with a few simple questions, we've narrowed the range of possibilities to a very narrow range without actually measuring where the ball is, observing the ball, or doing anything of the sort. So this is kind of one way Bayesian inference can be used to establish or set a range of possibilities for things that you don't know very well. And in the marine environment, there's a lot of things that we don't know very well. So an extreme example of this is a guy named mathematician Laplace estimated the mass of Saturn using exactly that method as the pool table, only instead of 3 or 4 cue balls or balls on the table, he asked his mathematician friends to give him as many bits of information that were relevant to what the mass of Saturn was as they could come up with. And so they would calculate things based on the orbit and the ideas of what they thought the range to Saturn was and things like that. And they gave him 125 estimates of the parameters he needed to make this calculation. And he was interested in how the rings of Saturn worked, and to figure that out he needed to know the mass, so that's what's behind it. So he did this. Go ahead. And Laplace's solution was correct within 0.63% of the modern NASA determined value. So this isn't just about making some vague guesses about pool balls. This is a method that can be used with quite a lot of precision and with uncertainties that go along with it. Okay, go ahead. So, we can use the power of this basic principle to help overcome the inherently patchy, uncertain, and incomplete nature of marine or other types of data to help us, make decisions in the face of uncertainty. Okay, so this is the only other equation you're going to see. Don't worry about it too much. But graphically, this is a visualization of how you do that. And in the left panel, you see a blue probability density function. That's what PDF means. And it's the prior PDF. And that represents all the information that you have already before you do some experiment. And then the likelihood function is the data from some experiment that you just did. So, for example, a prior PDF could be decades worth of groundfish surveys or something like that, and then last week you just went out and got the new current survey, and that's the green one. And when you combine those together, you get what's on the right, the orange PDF, which is a combination of the probability of what you knew already combined with some data that you just collected. And so that's basically how we use Bayes' theorem to take in data that's patchy, sparse, uncertain, or collected at a different time under different conditions, and try to estimate an outcome based on a variety of those kinds of data. So in a system like this, you would have not just two PDFs there, but literally hundreds of PDFs stacked together to predict some outcomes, which is what's shown on the right. And there's a cute little picture of Reverend Bayes over on the right. So I've become a big fan of Reverend Bayes lately. Okay, so now the question is, why another marine spatial planning tool? And I think you can see where this is going, is that basic GIS functionality is wonderful. You can do incredible stuff with it, and especially in the case where you have very uniform, very dense data sets, you can do amazing things with it, like the map stack that you see on the left. The problem comes in when you start to have sparse, patchy, and uncertain data, and you try to do some sort of analysis with that data. So in a typical GIS operation, it's simple to assign values to a map, to stack up the raster layers and get a score for some variable you're looking for. The way it's shown there, and we're all familiar with this. And people love this because it's simple, the software is maintained by other people, and a lot of times for many things simple is good. But not always. It creates some problems. So the biggest problem as we see it is a lot of data sets are not very easily represented as raster layers. So interactions between raster layers typically don't exist in GIS-based systems. There's a word missing there. Uncertainties are typically not accounted for in raster layers. Temporal change, generally not handled well by GIS systems. Data often, because of problem number one, data often have to be aggregated or dumbed down or processed in some way to the lowest common denominator to be able to fit them into a raster-based process. And then finally, the GIS-based system produces data and produces some sort of outcome, but they don't necessarily really assist directly in making the decision, which is sort of our goal in this exercise today. Okay, so sometimes it's worth it to make all these compromises. A lot of times it is, but sometimes not. So here's just an example. We and the NOAA folks work on this HUD database, which is got 323 rockfish species in it and 4 life stages. So to represent that all of what's in that database as raster layers, you'd have 1,292 raster layers. So you quickly, to get a 4 or more dimensional database of any type, whether it's oceanographic data or groundfish data, into a GIS system, you've got to do a lot of simplification to get the number of layers you're dealing with down to something manageable. Okay, so there's our big stack. We'd like to do something a little different than that. And so what are we going to do? We're going to use a Bayesian type system. Go ahead on here. Here's our little cartoon of the evolution of statistics with our Bayesian guy over there at the right at his computer. And so now we're going to go on to the BAS decision tool and what's different about it.
All right.
Well, there's a couple more slides.
Okay.
So this is the login interface. This isn't quite the demo yet, but I'm going to show you just generally what you're going to see. Go ahead. And so the problem today, we're looking to choose a suitable location for a marine renewable energy device in the face of technical constraints, human use needs, and conflicts. And so you may have seen plots like this before. Chances of making a decision go down as the number of opinion goes up. And part of what we're trying to do is simplify that so that graph is flatter than it looks in this plot. Okay, so common decision-making steps. You want to identify the issue, very simple for today, wave energy. Identify some options, lots and lots of ways to do that. Evaluate some alternatives, what criteria you use for that. Make a decision, hopefully, and then implement the decision. So to get a little more specific, we're going to define an issue. Chris and Moore are going to do this in a minute. We're going to identify some sites that are relevant to that. We're going to identify some ways to evaluate those sites. Then we're going to invite some stakeholders and evaluate or gather their evaluations. Then we're going to actually fuse those two together analytically so we can produce an outcome that uses both stakeholder and science data, and then hopefully we'll make a decision. So the advantages to this are a Bayesian system is based on multiple hypotheses, just like in Science 101. There's never just one right answer. We want to see what the probabilities of being right are. Bayesian system reports on the probabilities for different outcomes and tracks uncertainty throughout. And the uncertainty business is really important, as the system is being built for BOEM and they have regulatory responsibility. And so there's additional pressure to have transparent systems that track their uncertainties throughout, that lead to defensible decisions. So a Bayesian system will tell you how sensitive the results are to the various pieces of information that it uses. And you can accommodate change over time. And importantly, the Bayesian system is not that sensitive to incomplete or patchy data, which is a big deal for us most of the time. Bayesian system can tell you what you could try next if the outcome is inconclusive. That's what BAS does. And the underlying data and models for a Bayesian system can be upgraded and revised anytime new information becomes available. That's not unique to Bayesian systems, of course. Any system can do that. So at the heart of it is a series of models that eventually become raster layers, but start out as models that predict suitability of something in the marine environment. In this case, it's suitability of a wave energy device or the impact of a wave energy device when it goes in. So as with everything else, it's garbage in, garbage out. So the models need to use the best science and data. Nothing magic there. And the models will change as understanding of the environment improves. So here's a really simple model of the Aurora rockfish out of the HUD database. And that's on the left. On the right, you're seeing the input for that, which in this case is substrate, latitude, temperature, and depth. And so we've reduced everything that an Aurora rockfish likes to those four simple things. This is just a very simple demonstration. And then the meter that's shown there is the suitability, probability of a spot on the map being a great spot for an Aurora rockfish. So in the HUD database, for example, there are going to be 323 species and 4 life stages. So fully representing that database is going to have 1,292 of these little models on the right. Okay, so here's just go forward. Okay. Here's the gray whale model and some of the things that go into it. We have migration depth, substrate type, forage depth, and kelp proximity, 4 GIS layers that could be used alone, but on the right is the model of how those things interact to produce suitability for a cetacean at any given spot on the map. Okay, so we're coming to the end of what BAS does, but here's the resulting output. It's a very familiar looking GIS layer, but what this is showing in the colors is the probability of suitability for those spots for a gray whale. It's not a map of gray whale occurrence or observation, it's a map of suitability for gray whales. Okay, so BAS focuses on measuring and processing potential change to marine and coastal resources from proposed actions and presents present and impacted future conditions. And so you're going to see a demonstration of how suitable a place is and how suitable it is after you put the wave energy device in. That's a key bit. So there are other conditions that are also relevant to decision making, like regulatory status, dredge spoil areas, tow lanes, marine reserves, and things like that. Those things are provided to the stakeholders and the participants as advisory data. They're not so much part of a science model, but people need to see where they are to help make the decision. Okay, and so here's a list of functions that are going to be in BAS. They're not all in there yet, but this is the planned list, the development list. I'm not going to dwell on that. And then we have a lot of different use cases. We're only going to demonstrate one of these in a couple of minutes. One would be just looking at the science measures only, just filtering for a decent place without getting stakeholder input. Another is mixing science and stakeholder measures together. That's more of a public meeting type setting. And then some, these things would include agencies seeking a good site, developers seeking good sites, agencies evaluating proposals as they come in, and then there's probably many more scenarios that you could also dream up. So, once you've processed all the science data, you still have to make a decision, and that's what we're going to do in the demo. So, let's go to the end. So if you guys got any quick questions, this would be a good time. If not, we'll just push ahead. Okay.
I have some, but I'll wait because I think I'll maybe understand a little bit more about it after we get the demo.
Okay. Sounds good, Andy.
Let's see if we can switch gears here. So, thanks, Chris. We're going to give you a hands-on live demonstration. So Chris introduced you, I think you all saw the login page, and some of you have test-driven the system already, which is great. So I'm going to log in, and I think Andy and Todd and Tanya and Paul may already have done this. Okay, so I'm logged in right now as a manager, and when you first come in, what are we going to do here? So the objective is we're going to give you a demonstration of one of those scenarios Chris just described, and the scenario is we're going to use the NIMRIC PMEC siting or site selection process just as an example. So I'm going to show you sites from that process from the perspective of a NIMRIC, I guess the head of NIMRIC, with a need to select one of those 4 sites to move into a permitting phase. So selecting one from a subset of 4, the scope of that, I needed an example that we could kind of get through in 20 minutes, but the scope of that is going to include one additional stakeholder from within my agency or my organization, and that's going to be Morgan. He's going to be my proxy stakeholder, and he's going to bring his knowledge, which he may have a specialty that's a little different to mine, to this problem. So there are going to be 2 of us, a manager and a stakeholder. So we're going to do that mixed analysis. We're going to look at objective science measures and a few 2 subjective stakeholder measures. So when I come into the system, I need a project set up for this analysis, and I have set one up already called the DLCD webinar. But when you have interacted with it, you probably had nothing predetermined for you. So a manager would come in if they needed to and set up a project by developing a project with a description, naming it, describing it, deciding on the technology that was going to be evaluated in a phase of operation, deciding on granularity to run the analysis, to run the scientific measures at. I've already pre-selected these. I've used the default conditions here for the analysis, with the exception of I turned the granularity up to 250 meter. But that's what we see as the DLCD webinar project. So I'm going to load that. And the next step in the process is you need a couple sites to work on. Again, they're preloaded for you here, but you can edit them if you'd like, by selecting one, changing some information about what it's called, or most likely you're not. When you first start up, you have nothing, and so that Chris mentioned another component of the system that can be used to advise the process. That is, we have a web map server that you can launch from the viewport here, and I'll just briefly toggle over to it. But here we're presenting information from web services of our own and web services that we've aggregated from other providers, multi-purpose marine cadastre, NOAA, marine protected areas. So I have a couple layers turned on here, but the manager can, I've actually loaded some case study specific site information, but you can interact with this to pre-filter to come up with these sites, and maybe get corner coordinates, map coordinates and such. So I just wanted to throw that out really early in the demonstration that there are advisory information we feel is really important, and we want the manager or the stakeholder to be able to have access to that at any one of the phases. As we go along the top here, you'll see I'm toggling to different phases of the analysis or the decision-making process, and at any time you can go, and you should, consult the best available information if you need to go out. We've just tried to aggregate some of the useful stuff, make it really easy to get to it. So I left off, before that kind of went on that description of the display port, I left off with entering a site. This is just some stuff to get out of the way at the beginning. It's simple to enter a site. I might want to just to define a new, we call them areas of interest. So I selected define an area of interest. I click on the screen, I give it a name, foo, and I change the corner coordinates, and I give it some dimensions. It's going to be a 10 meter by 10 meter box, or 10 kilometer, thank you, 10 kilometer by 10 kilometer box. I'm going to dismiss this now, because if I make a change for this live demonstration, if I make a change to these initial 4 sites, that's changing the conditions or the places that my scientific measures need to be processed for, because the scientific measures are going to be processed, are going to provide you a probability estimate for each measure at this box. So if you change the size of the box, and I don't want to do that in the middle of the demonstration, so I've pre-run my science measures for these 4 sites today, and I've done that by there's a button to do that here that we provide actually at every page. And the typical scenario, I think the most useful way to do this is to have the manager run those scientific measures before getting a wider stakeholder community involved, before you go out to stakeholder data collection or get yourself into an evaluation of the results in a meeting type setting. We run the models, and because there's a time penalty for these 4 sites. It's about 10 minutes. It's actually really fast, but that's not something that is suitable for the late stage evaluation. You don't want to be waiting on a model run when you're trying to explain the results. So I've loaded, this project has come preloaded with sites, but I encourage you guys, you'll all have usernames and be able to create your own projects from scratch, hopefully after this demonstration. And that's the quick and dirty way to do it, is just to define the new area of interest and click on the screen. We also provide a full explanation of this in a help file at the display port. So there's a quick start guide, there's a user guide, there's a description of scientific models, so you can drill down and really get some additional information about how to use the system. Okay.
I had a shapefile with a subset of areas. Can you load that in?
Yeah, Andy, the only way we provide defining areas right now is to type in the corner coordinate and the size of the box. But that's something that wouldn't be a hard thing to develop, to have load a shapefile as your areas of interest. But right now, you need to kind of do it in the rectangular sense and manually. That being said, the models can handle an irregularly shaped polygon, but right now we limit it to manual entry. Okay, so I've got 4 sites for consideration in my NIMRIC PMEC decision process. The next question, if you kind of think about, Chris had that nice flow chart of what the next thing we need to do as a manager, myself as a manager, is come up with some measures, both scientific so objective and qualitative, subjective measures rather, that are going to help me actually make a decision. So this is our full list of scientific measures here on this kind of scroll box, this list box. I have selected all of them except midwater device for some reason. But you may, depending on this problem that you're involved with, for permitting reasons, you may, if you're just trying to meet the letter of some permitting, passing the bar on some permitting thing, you may have you may only want to look at a couple measures. If your concerns and your decision process needs to encompass different public sectors and their feelings about it, so the list would grow. So there's a phase where you're determining which models are really important to your problem, and that is up to you as a manager in knowing what bar do I need to pass for my permitting, what sector do I need to satisfy. So I've got them all selected here for an example for this particular project. Okay, so we are done with scientific measures. We've selected them all except for midwater. It's device suitability. And now I mentioned that there's one other stakeholder here, and he's Morgan, and he's got specific knowledge that I would like to capture. So I'm going to provide my own input on a stakeholder qualitative measure, and so is Morgan. So we've loaded 2 people up here. You can load more. I'm the manager, so I get to see, I'm the only one that can actually create or destroy measures and change their things. But I need at this point, I need qualitative stakeholder measures to do data collection. So one of the, within the scope of this kind of case study example project, we developed 2 stakeholder measures that we are interested in having more information about. And one is how does the siting of a marine renewable energy technology, a wave energy device, at any one of these sites impact the stakeholder's sense of place? That's the top measure here. The other one is how does the technology at the site impact existing ocean uses that are already using that space, or what's the potential for conflict? We think that this conflict and sense of these 2 stakeholder measures help us provide another piece of information that the purely objective measures didn't quite capture. You can create additional measures. And you can also choose between a qualitative or a quantitative style of measure. One example, you might develop a measure that was a measure of job creation. So at site number CS2, what is the impact on job creations? And I'm going to be delighted. My most desirable site you would enter in 100 jobs, or whatever the manager deems to be the most desirable condition. So you can set them up as either qualitative or quantitative. That helps you pick apart the results, but the data collection is the same, whether it's qualitative or quantitative. So I've just got 2 preloaded measures here. I'm going to invite some stakeholders to provide their input. So I've selected myself, Morgan. This could be if this is a public process, this is a long list, and you can do a group, a broadcast email to your stakeholders, and you can provide them with, I'd like to have my results back by the 14th of the month. I'd like you to do a belief map evaluation. So what I'm asking you to do is provide your opinion on each site for these 2 measures, and you can give a little preview of the email, but you can actually send the invite. And I encourage you to test this. I sent Morgan an invite earlier, and he gets the instructions in the invite for how to go provide his input. So at this point, I've I've got my stakeholders. I've got all my measures set up. I'm ready to, my scientific measures have been run. I ran them in advance of the meeting, so they're available. I need to do data collection from the stakeholders now, or I'd like to do data collection for the stakeholders. So we're moving along in our processing path. There's two components to this. The first component is we collect your views, or this per stakeholder rather. What are the most important measures to you? So to me, as the NIMRIC supervisor, has the will be putting a site forth for permitting. I feel that I've done a little bit of work about suitability. I feel pretty good about that my sites are suitable, but what I'm really trying to do here is I've moved these stakeholder measures up to the top. I really am concerned about, I don't want to propose a site that, and I'm playing a role here, but I don't want to propose a site that is a non-starter in the community because there's ocean use out there that just is off limits for certain sectors, or really is hitting somebody's sense of place. So I basically what you're doing here is you're setting your own personal weighting. And Morgan, as the other stakeholder, I've invited him to do this also. Every stakeholder provides their own ranking. You can do it so this way sets the score for you and just reorders it by the position. The other way to do this is to toggle over to the sum method, where they're all equally weighted, and maybe you just want to promote one over the other, and you can make adjustments on a per measure basis. There's two ways to kind of do that. I'm going to go back to the way I had previously set. And then you save that evaluation. So that's now that gets written into the BAS database. Second step to this is to do the site-by-site evals. So what I'm showing you here is a belief map, and on the y-axis is desirability. As you go up, it's more desirable. On the x-axis is your certainty. So I like to do these by showing all sites for a particular measure. So here I've selected my sense of place measure. I can change it to the ocean use measure if I want, but just one measure at a time here is the way I like to do it. But I've turned on all the locations because it's a qualitative measure, so what's important here are how their position relative to one another is important. And what I've done is the blue and yellow sites are CS1 and CS2, the Newport sites, and the pink and green sites are the Coos Bay sites. And the information I'm providing is that I find that the southern sites are less desirable, have more of an impact on sense of place for me, the stakeholder, than do the Newport sites. And the other thing, by separating them on the x-axis, I'm telling BAS, I'm providing an estimate of my certainty. I'm saying that I find these sites less desirable and I'm more certain about it. If I go to, and I've done the same thing, so this is my evaluation for existing ocean use. I find that the southern sites, given my experience and my understanding of ocean uses, that the southern sites probably have more potential for conflict than do the northern ones. This might not reflect reality, but this is my evaluation as a manager and what I bring to the table and my understanding. And then again, there's a little separation in my certainty. So you see, I feel that I'm more confident about my assessments of the southern sites than the northern ones. And Morgan's done the same thing. Morgan sees differences between the northern and southern sites for both measures, but he's a little bit more confident in his assessment, and that's why I invited him, because he may be my expert for any one of these. measures. So here, at this point, we've done our data collection, our stakeholder data collection, save our results, and we want to know how does it play out. So I got a little message up here that it's successfully loaded my scientific measures. So it's read from its cache. It says, okay, I've pulled in my scientific measures. I'm ready to go. You've just saved your stakeholder evaluations. I checked to make sure Morgan submitted his on time. His evaluations were there. He's the only other person. We're ready to go. We don't see anything on the screen here, and that's because my threshold, my satisfaction threshold, is set at 50% by default. So overall, none of the sites score better than 50%. So I'm going to bring this down. I'll bring it all the way to 0 so we can see what they do score. So what we're looking at now are the composite scores with each stakeholder's weighting applied, the scientific measures satisfactions, and the stakeholder measure scores. So this is in aggregate. And unfortunately, there isn't a lot of separation, but we do see that the northern sites are a little bit more suitable in when we consider qualitative and quantitative measures. What we provide for here is changing your viewpoint. Let's take a look at this from so that's everything, qualitative and quantitative. We might want to look at this let's take a look at just one of the stakeholder measures. If we look at the impact on existing ocean uses, we can see that we think that what we see here is that the Newport sites are getting a higher score. So we see there is separation. So what this is helping the manager do is allowing them to drill down to see the different sectors and how each measure plays out, how maybe Morgan's measures are weighted, how my measures are weighted, how overall. So we can see. So you can see it as just a percentage or satisfaction level. We also provide a little graph, another way to see which site wins. And so that's really helping you get to, like Chris, making the decision, and your decision would be made on your decision rule that you developed at the beginning of the problem. It may be explicit. If it's a permitting thing, the decision, you must provide for a certain level of support for cetaceans. I'm trying to scroll up. That may be a permitting requirement. So you may have a target that you need to get to. It may be expressed in a level of support, or not to exceed a certain level of impact. Or you may have your own internal targets that you're looking for, minimizing impacts to, or minimizing the potential for conflicts. So that helps you apply the result to that decision rule, is the point I was trying to make. And we give you you can slide up to see. So based on I didn't enumerate or identify at the start of this what my decision rule was, because I wanted to kind of leave it open to let you think about how that plays out. We also tell you maybe what to do next. It's just taking a minute to look at the results, but what this is doing is it's saying that there's low consensus around what you could do to tighten things up, and this is really so you might go to refine your criteria, or develop stakeholder alternatives that actually are a little bit more differentiated. So it's giving you suggestions for maybe how you might better extract information that will actually help you make a decision. So I hope, I realized that I'm already like running a little longer than I expected, but what I was trying to do here is give you enough information that you can start back here at the beginning, develop your own project from scratch, get your own sites loaded in, because get you familiar with the procedures of going step by step along the path to the end, more than trying to pick one site over the other in the demo. So I guess it's a good time to maybe ask the question of you guys that, how did you, is there anything you would like me to go back? Is it something that maybe have a question about in the flow of things,
Yeah, we've got a bit of time for questions. We're close to on time, so fire away if you've got some.
Yeah, so this is Andy. My question is how you go from, I guess, in the evaluation, you chose effect on cetaceans on those 4 sites. What are you measuring there when you say the effect on cetaceans? That's the.
Gotcha.
So you're asking it I'm wondering the input and then the analysis function.
Sure.
So the input is the model results, and if we go back to that like gray whale model that you showed earlier, that would have been the input, or?
Well, there's a couple of things going on. There's a scientific evaluation, and that's what was in the early part of the slideshow, where we have
right.
a decent model of what gray whales like, and this is where we should find gray whales, barring some other, issue. So that's the scientific measure, but then when you get to the stakeholder side, you first ask the stakeholders, do you care about whales? Is this relevant to you? Do you care about them, and how much? And then the third input is when the individual stakeholders look at the individual sites and say, okay, what do you think what is the impact that we're suggesting might happen? What does that mean to you as an individual for this individual site? Is that important to you? How important is it? And how certain are you of your feelings about that? And so at that point, we would have the scientific measures displayed for people so they can see what we think the impacts are going to be. And then they make their judgment call about, how they assess that. Do they think that's important or not? And that's the heart of it. So on the science side, we also project what we think the impact on the whales is going to be by putting in this particular type of device in this particular spot. If it's right in the path of their migration route, the impacted value is going to be significant. If it's a blue whale and they migrate 20 miles offshore and we're looking at an inshore site, then the impact would be minimal. So we have an initial value of the suitability for whales, and then we have an impacted value after we build and install this device. And we even go down to the level of impacts during the construction phase, during the operation phase, and during the decommissioning phase as well. So you can assess those separately if you want. So those are the basic inputs, and then the BAS system fuses all of those to give you an outcome, which is what was on the map at the end. Does that help, Andy?
Yeah, no, that's very helpful to see how both the science and the stakeholder pieces are put together, because that was like one of the things we heard the most was this big concern about effect on whales. So
right.
If I was playing the role of a stakeholder, I would have pushed that concern up on the kind of a public concern spectrum.
So that kind of
right.
would be, as a manager, when you're doing your evaluation,
yeah,
that would be like this, moving. I think what you're saying is that's driving the problem. So if you need to make a decision based on that decision criteria, and weighting it at the top sounds like where you guys are going, and that this is kind of setting the weight applied to the measure.
Yeah. So when you the idea here, I mean, part of the whole point of this is not just to build a cute, better mousetrap. The idea is to kind of defuse some of the shouting matches that happen, at public meetings when you typically present the data, and then you kind of throw in this chunk of raw meat into the Coliseum, and people yell and holler about it. And the idea here is to just kind of, in a civil way, collect their input about how they actually feel about it, and why, and how strongly and how certain they are, and then present the data to them, present it back to them, and say, well, it allows you to do things like say, hey, you guys are very, very excited about this shrimp fishery thing that you came to talk about, but actually the decision is being driven by whales, so let's talk about whales instead. And then drill down to see, well, what is it that's driving the decision about the whales? Is it the device type, and maybe that needs to be shifted to a better spot, or whatever you need to do to kind of resolve the conflict, and put it on a more objective basis rather than kind of a shouting match. So that's sort of the idea.
Okay. Yeah, that's helpful.
I was trying to show you, just if you were watching the screen, I was trying to show you that you can actually get to the model. That's a
So when you get your
model.
When you get your reports back, and you as the manager of the process, you're acutely aware that everybody's interested in whales in this process, like you just said. Well, the first thing you're going to do is you're going to throw up the whale model on the screen and say, okay, this is, and that in itself is going to generate a lot of discussion, like, where did you get your data from? What's in this model? How does this work? I think your data's full of crap, and all that stuff that you usually get. And you talk.
Well, yeah, like when I saw it, I was like, okay, well, it looks like we've maybe conflated two different life history modes in that same model. So might it be more appropriate to pull that out into two models, one for migration and the other for the whales that
foraging
on our coast and forage? Yeah, exactly.
Right.
So that's exactly what you do. And the way we recommend to do the process is you'd essentially have a pre-meeting where you hash out all those details and have everybody agree on what the ground rules are. We need a forage model. We need a migration model. Well, that might trigger we don't have a forage model. We better go to Bruce Mate or whoever we need to talk to get a better model for that. And then you make sure you have all your ducks in a row, and then you come to the public meeting where you can truly present the best data available. Because you know what's going to happen if you just walk into a meeting and say, here's our new black box, we've got all the latest data. You're going to get shot down in about 3 seconds. You're never going to have all the latest data on your first try. And so a real process like this is going to inevitably be a multi-step thing where you first look at the models that you have, vet them, find the holes, try to plug them the best you can, and then carry on to the next step.
And so a model like the cetacean model, which has several different inputs. I think it has a total of 4 different inputs in this particular.
Do you want me to go back there?
Sure. Yeah, let's go back to it. I believe it has 4 different inputs in here. We have 3 for the forage, and then so 3 for forage and 1 for migration. The migration is primarily constrained by depth. When we're looking at site-by-site comparisons between them all, each of these different inputs, if you scroll down, has a series of different possible states within each input. So we have these depth bins that you see at the top there, and then we have different substrate classifications that are supposed to be relevant to the food object of the whale in this case. And then we have depth for foraging, and these different environmental attributes all relate per that score that you see in those tables to how suitable that location is for a whale, for instance. And when we look at a site-by-site comparison, what the model does is it runs through all of those individual input attributes and samples them, and then develops a distribution across each of those input states of what the different states are. So if your entire site is all within one depth bin, you'd wind up with one of these depth bins along the bottom left pegged at 100%. However, if your site was across a wider, broader distribution of depths, you'd wind up with more uncertainty over over your ending score for that location as a result of the heterogeneity of the input data sets within your sites. And that comes through as part of the actual ending evaluation and part of your certainty about it in terms of what the model's returning. So that's kind of analogous to what we see in the stakeholder input. We're saying this is how suitable it is, and then this is how certain we are of that. Well, the models are sending out a very similar thing. They're saying this is how suitable it is, and this is our certainty of that as a result of what the input data sets are telling us about heterogeneity. We have the ability to input, if we have information about it, we have the ability to put input distributions of satisfaction across each of those states for each of those nodes, according to something that might be expert opinion or might be learned from a data set. And so that allows us to incorporate uncertainty if we have that knowledge into the modeled end of this.
Oh, like the
does that make
HUD,
sense?
like the
Yeah.
So I'll just add one more little thing to this very long answer, is that if you in the real world, you're typically going to be dealing with we're obviously not whale experts, we're not pinniped experts. We with Parametrix and others have built these models, but inevitably, you're going to run into, oh, hey, this new paper was just published. It's got a much better blue whale model than we've ever had before. Can we get it into BAS? And the short answer is yes, you can. It may be that there's two ways to do that. One is you can construct a new Bayesian model, which is going to take some advance warning. But the shortcut way to get it in there is if they have it represented as a raster, we have an ability to plug in a pass-through model, which BAS can use that data and build it into the process, but without going through the step of building a new Bayes node, which you may or may not have time to do.
so you could use both. You can use combinations.
Yeah, that's not the most robust way, but we built in the ability to do that. So more questions? We're actually technically out of time, but we're happy to stay and talk as long as you want. We think it's pretty cool.
This is Paul. When you dry run this thing amongst yourselves, how many stakeholder inputs did you, let's say, test out on a given, sort of project?
I think we've run it with about a dozen people or so. I don't remember the exact number.
Stakeholders or measures?
Yeah.
Stakeholders. Let's say you
actual people. Yeah.
Right. So you just dry running the model. You want to see how it works. So
Yeah.
you invite.
We've tried it
You
with
invite a number of people. How many at any given time? How many people would you invite in, and sort of would you assign them, certain kind of stakeholder attributes to return or something?
Yeah, we've tried it with about a dozen in a live demo. We haven't tried to see where the limits are, and for the type of stakeholder evaluation where you say mail out, email out invitations, and you may have, say, hundreds, maybe even thousands of people responding to that, there shouldn't really be any limit there, as they're all going to be doing this one at a time. There probably is some limit in a live public meeting, but we're not really sure you'd ever do it that way in a live public meeting, because everybody would have to be sitting at a computer simultaneously, and that's probably not going to happen in real life. So if people are doing it asynchronously as they have time in the evenings or whatever, there shouldn't really be a limit to it, but we haven't tried it with hundreds or thousands.
So you envision this as being sort of a desktop operation?
Well, ideally, that's kind of a neat, clean way to do it, but it does depend on some computer savvy among the stakeholders. And so a lot of people are going to say, hey, I don't have a computer, I don't want to learn this, what can I do? And in that case, they would just fill out a paper form and we would just enter the data for them.
But in terms of stakeholder participation, a lot of what you've seen here today in this demonstration was geared really towards managers and a manager working through development of a project, setting up the stakeholder measures and the scientific measures that they're interested in, and then moving forward with that. And the only element of this that a stakeholder actually sees when they receive an invite to evaluate the thing is that part where we're assigning our value structure to the measures. We're sliding them up or down or left or right, and then the belief map assignment. So that's really the only part that a stakeholder will have interaction with, which is pretty limited relative to. Go ahead.
They'll be able to view the science measures as they're doing this, though, of course.
Yes, yeah, that's correct. They'll be able to go to like the VAS viewport that we've set up so that they can look at it and kind of get an idea of what they're evaluating on. However, their actual interaction with putting information into it is relatively limited.
So they can slide their bars.
Yep, they can
That's
slide
it.
bars up and down, left or right, and they can move those dots on the belief map to identify what their certainty is and what their satisfaction is for a given site and a given stakeholder measure.
So what are your concerns regarding the fact that stakeholders are going to want to try as best they can to manufacture a certain kind of outcome by sliding the bars? They're going to try to figure out, how they can manipulate this thing to get some sort of an outcome that's favorable to them. What do you think about that? Is that accounted for? Do you think it's accounted for in a balanced way or something?
I think there's no. That's a really good question. It gets into human psychology and all, and there isn't a perfect answer for that. We sit around and talk about stuff like that all the time, and you guys and we've been to lots and lots of public meetings where the guy who shouts the loudest has the most impact, and a lot of times the quiet, thoughtful person doesn't necessarily have as much impact, even though they might have given a much better response. And so one thing that this thing does that we think is good is it just evens the playing field in that kind of a setting.
They each get the same.
They each get one. Yeah, you get
they
one.
They all have the same tool. Their voice sounds the same.
One vote.
Right. They get one vote, and even if they type it in all caps, it won't have any more impact.
Well, that's what Terry Thompson
else's.
brought that up at the demo, right? And it was,
yeah,
who you invite, you need to think about.
Yeah, you do need, you as a manager of a process still are going to have to be involved and take care to invite the right people and have it evenly spread over the population. But really, if you have more than a few dozen people involved in this and they're sliding the bars to get only the outcome they want, I think that's actually okay.
Yeah.
They're going to be highly diluted because their vote is going to be diluted by everyone else's, and it's also going to be diluted by the really objective science measures. So I think it's going to be harder. I mean, that's really one of our primary goals, is to make it harder for very outspoken people to kind of spoof the system and do that. So, but it won't be perfect, that's for sure. But great question.
Yeah, during our last process, it became clear that, when EcoTrust went out and did their fisheries mapping exercise, and then the groups, kind of vetted the results, it was clear that they had a specific purpose in mind. They were really going through that exercise with, the idea of keeping marine reserves out of their area of interest. And it came back to haunt them a little, because an area that they said was really important, like Langlois, didn't show up on their maps.
They had an alternative, ulterior motive for why they, configured the data in a certain way.
Yeah. I mean, I saw that same thing happening, and it's definitely frustrating. But what's going to happen here is if you do that, the scientific measures are going to produce an outcome, and then I think it's going to be more obvious when people are trying to spoof the system that they're tweaking the system is, may conflict in a very obvious way with the science measures, and then it'll just be harder to defend an odd position like that.
BOEM staff have gone through this and tried the tool out, right?
Well, we're doing that in parallel with this, so we're still actually kind of learning how to do that, and we gave it to our a group of the NOP partners, the National Ocean Partnership Program, to test it out, and we sort of set them up in a way that was destined to fail. We made them all managers, and it all got pretty screwed up. So we're going to have to redo that, and if they'll be patient with us to do it with a hand-holding demo like today, and then maybe doing it one at a time. But we just so we're doing that, and the first feedback we're going to get is probably going to be highly negative, because the method we gave them to test it wasn't tested itself. But hopefully we'll get past that and get them to get a nice, good, clean test of it.
Well, I think people's attention, at least initially, is going to be focused on the input models. And I think so that'll be will be important, because I saw the fisheries model in there, and I saw, as I said, lots of people were concerned about whales or the view shed.
I think you're right. I mean, people do fixate and argue about, and rightly so, all the input data. And I don't want to tell you that we've spent years and years developing perfect models for each one of these icons that you see on the screen. That's not the case at all. So getting those models right in advance of a real process is part of the process, as you know.
Yeah, I was just going to say that's going to be a really valuable part of a discussion going forward. Is do these models accurately reflect reality, and if there are changes to them, what should they be, etc.
Yeah.
So I think it's great that you've put all this together in a way that it can be used analytically. I think that's going to be very powerful.
Yeah. Well, thanks, Andy. Thanks. I think we're really pretty happy, and we've been kind of struggling with the mechanics of it and stuff, but now that it's starting to work well, we're feeling really good about it. But we definitely don't want to oversell the models themselves. Although Morgan's really worked hard on them, they're a starting point, and anybody who looks deeply into any one of those models is not going to be fully happy with it by any means. And there's lots of models that are simply missing on the page there. So this is the Mark 1.0 version. It's probably usable as is, but I don't think you'd want to launch this into the public without that kind of first phase of the project I mentioned, which is before you get the
review them.
Yeah, before you get the public involved, review them carefully, build new ones as needed, and then plug them in. But that's not the hard part of the system. That's actually relatively easy to do. But you're going to do that, you're going to have to pull in whale experts and all the right people to get it right.
Well, and one of the things I was wondering along those lines is just when the last time you got updates of data from like our ecological atlas or our TSP catalog, so that if you were using this data for another siting process in Oregon, those inputs would be consistent, or at least the model inputs would have those additional data to work from.
Okay, I'll let Morgan respond to that one.
So at this point, the data that we're using in here are data sets that came out of an assessment that Parametrix did for cumulative effects and cumulative effects framework for the OET program. So at this point, the data sets that are being used as the base attributes for this don't include that. However, as we identify data sets that are better, newer, more appropriate for base level attributes, it's not hard at all to put those in at the base level for the models to extract data from.
I'd always kind of envisioned keeping track of that, documenting that in the model documentation, where they're coming from.
Yeah, and that in terms of being transparent and making sure that this stuff is we're not trying to hide anything. So in terms of being transparent in that regard, that would keeping track of what we're using, where it's coming from, is something that we should probably push forward with. Does that make sense?
Yeah.
Okay.
But I just remember that when they did their assessment, they asked me for a data dump, right? So these things have gone in circles already. And
Yeah.
the last circle that we went through was 2 years ago, 2.5 years ago, something like that. So since that time, we've definitely developed additional data sets that you're going to want to have as inputs, and we're working actually this month to make sure that we have all those things cataloged and
It's not going to be
available. So,
through the data atlas.
we'll have a catalog of those things available, and then we're working with ODF&W on standing up of their own kind of catalog, so to speak. So the information that came out of the ecological atlas should be cataloged.
Yeah. I mean, that's always a moving target, and
Yeah, it always is, and I recognize the difficulty in that. But
yeah.
we
So
should at least make the effort and the attempt in the near future to get that in.
yeah. So our on our wish list, probably number
Yeah.
one on our wish list for the next, our push has been to get basic models in there, get it running, make sure it all works, debug it, and all of that. But the very next thing on our wish list for our next phase is to bring the models up to date, the input attributes up to date, flesh out, gaps in the model set that we have, and all of that. And we're not quite there yet, so I wouldn't suggest that we should just throw this out and deploy it right now, because that would be embarrassing. It's not ready for that.
Version
But-
1.1.
Yeah, version
I
1.1.
was looking for that.
So
Yeah.
of that model.
Yep.
Yeah.
so that's exactly what needs to come next, is to bring it up to present day. But we need to identify resources to do that, and a path to do that, and we have to make our BOEM funders happy to do that, and all of that. So it's definitely super high on the list.
Great. Well, I think that I don't have any more questions.
No, I think most of my questions, this is Paul, are going to be directed towards BOEM and how they anticipate using this tool and how they account for a lot of other factors that this system doesn't account for in their decision making. Just what is it? What part of the decision would they use the BAS tool to help them with? Because it certainly doesn't account for everything they need to consider, and I guess that
Yeah.
question is for them.
Yeah, I think they're still thinking about that too. I mean,
Yeah,
we
better be.
yeah, I mean they're sort of charged with making these sort of regional jurisdictional decisions, and they're not, even though they've been used to making decisions like that in the Gulf Coast for oil exploration, this is kind of new territory for them, and a completely different set of rules, completely different set of types of stakeholders and issues, and I think they're not anywhere near done coming to grips with that yet. And that's why they're really kind of reaching out for a tool that would help them. And so that
I'm just curious to understand how they would use this. At the same time, they're getting input from NIMS and NOAA for things like, marine mammal protection, whales, anything that has to do with endangered species, and they're getting inputs from Coast Guard on things relative to navigation, or the Defense Department on things relative to a black box they don't even want to open up, and
Right,
how does that move their box around, anyway, this is part of a package of things they'll be using, but
yeah, I
I
mean,
understand how they'll use it.
we're not 100% at all sure either, but that's a good question. We're trying to build the capability in that we can plug in as needed, even as pass-through models. Some things like, so we started building some simple models for navigation routes, even for aerial navigation routes, in case we're building some sort of a wind device that sticks up in the air.
Well, that's what will be out there are going to be wind devices that project up 500 feet.
Right. Well, the Navy uses that for supersonic fighter maneuvering out there. So
Yeah,
you're
how
going to
about
get some.
that?
The Navy is not going to like that one bit.
They're going to run that little bar all the way to the right.
Yeah. Right. Right. I really care about.
Make a call. They're going to call somebody.
Well, that's exactly.
My priority is fast jets.
But a lot of that comes out in pre-filtering of
Exactly.
sites. Like, I mean, this is stuff that before they ever get to the point where they're actually doing the sliding of the bars and whatnot. That's a pre-filtering of sites. I mean, you can't even begin to think that, oh yeah, maybe I can put it out here if that right there is exactly where the Navy's going to be running jets. So
I was thinking the BAS tool will be something they apply at the latter stages of a process where they've already accounted for a lot of things that this simply can't account for very well. And
well, we kind of designed it to be useful at both the early, middle, and the late stages. So in the early stages, you could do what Morgan just said, basically to filter out all the places that you just can't go for various reasons. And so BAS already does that. If you feed into it marine navigation routes, marine reserves, submarine operating areas, whatever, as shapefiles, as pass-through models, you can simply filter out all those areas that are out of consideration. And then you can take it to a middle level and then a fine scale just by varying. You're kind of varying the inputs and you're varying the players. Who are the stakeholders? At an early stage, maybe the only stakeholders are agencies or military services. But at later stages, you get down to actual people that they're going to see it out their front window. So
yeah, they might not have 0 and 1 kind of in and out areas defined, but they can be. You can ask them the right stakeholder question and get their agency perspective.
Yeah, and
on
even
a site-by-site basis too.
And a lot of things aren't givens either. I mean, you can invite the Navy to the meeting and say, can we move your practice area a few clicks to the north because this is a really great spot for something else? And they might just say, oh sure, no problem. Or they might say if
shoot you down.
if you put something out there, we're going to shoot it, or whatever they're going to say.
it'll shoot you.
But I mean that's also an opportunity to use the viewport there that we put together, which is just a map server, where we've tried to preload a bunch of information. We have stuff from the Marine Cadastre. We have some shape files for areas that are off limits in terms of air practice and whatnot, and that's an element that we can.
The advisory,
yeah, that's advisory information that we've tried to include in there. Now, certainly we've never, we can't claim to have it all in there. However, it's not very hard for us to add information. So if somebody came to the table and was like, hey, we're looking at putting something out here, and the Navy was like, well, we've got submarine stuff that we're interested in there too, then that's information that if they gave it to us, we could add in here and have available for some of that pre-filtering.
So Chris is turning on some of those sort of advisory types of things.
And one of those being, like, say, that layer that we developed on research facilities. And
oh yeah, I have that.
Yeah, I think we have that layer in there.
Yeah.
Yep.
Excellent. Yeah, that's what I was talking about. Cool.
Yeah.
Well, I think we exhausted ourselves.
Yeah, you guys did a lot of great work, and we'd love to slurp up all of that we haven't already slurped up. But.
Well, we'll return to this after we get some input from BOEM on what their intentions are on this.
Yeah. Okay. That sounds good.
We kind of hogged all the time for questions. Was there anybody else who joined in who had other?
Hey, this is Ann Radel with Parametrix calling. I've been just enjoying the opportunity to hear other people talk about BAS and their reactions. I guess, Ramzos, do you want to talk a bit about follow-up to this for the folks who attended? Or do you want me to?
Well, we discussed, I want to make sure that everybody has access for testing purposes, and I don't think that everybody at the LCD does yet, so I will send you a username and password.
I think we all got them.
You did?
I got one. Andy has one. Todd doesn't have one. Maybe he wants one.
And then I believe, Ann, you wanted to do a little follow-up and like formal.
Yeah, we have it's designed to be a fairly minimal commitment from you all, but we do have a survey, an online survey that we're asking people who have a chance to test Bass used to provide us with feedback to improve its functionality. And so I will send you all a link to that.
Great.
Yeah, that'd be
Yeah.
terrific if we could get some feedback from you guys, because that's this is really being built for you, and we want to make it work.
Thanks for the reminder, Ann.
Yeah, so that's all I had, but I guess thanks everybody for your time and participation, and Chris for the demo.
Yeah. Appreciate
Okay.
it.
Yeah, thanks for your time, guys.
Have a good one.
Thanks, everyone.
Thanks a lot.
Great, thank you.
Have a great day.
Thank you.
Thanks, guys.
Nice work.